Okay, so we did number 4 yesterday. I want to move on to 1 and 2 really quick because those are super easy to do. Okay, number 2 is the easiest one on this page because it's already factored. Can you explain to me why number 2 is already factored? That's the response I don't want. Remember, there's 2 things that tell you it's factored. There you go. There's no exponents, there's no GCF, so there's nothing you can take out. Okay, so this is technically standard and factored. We're going to leave it as it is. First thing I want to look for is RD. Look at your notes from yesterday. What does it mean? What factor was taken out? Okay, so was there a factor removed from the denominator? So anything simplify right now? It's a yes or no question. No. Then what is the RD? None. Because nothing got removed. And to answer your question, well, what does it mean if it is removed? That's when you get something that simplifies and it divides out. Here we do not have that, so there are no removable discontinuities. Okay, that's fine. And vertical asymptote, looking at your notes, we want to know what is not removed in the denominator, which is x minus 4. And we know that that's a discontinuity if the denominator is equal to what? What causes it to be undefined? If the denominator is equal to 0. So what x value will make this denominator 0? Positive 4. So my vertical asymptote is x equals 4. Because if I plug that in here, we get a 0 denominator, and then it's not defined. Okay, the last characteristic, HA, horizontal asymptote. Do we find that by what's not defined? We find that with the behaviors of the graphs using degrees. So what is the degree of this variable if you don't see the exponent? There's 1. Same thing with this one, right? So the degree in the numerator and denominator is 1, meaning we use which rule?
Or
same degree. So we divide the coefficient. I don't see a coefficient. What number's in front? 1 divided by 1 is? Okay, and if it's my horizontal asymptote, is it x equals 1? It's your y values, because it's talking about your outputs. What do the outputs approach? What's the behavior of them? They go to 1. Question on that one? That's like the easiest it could get for you right there. All right, moving on to this one. The only reason why this one gets messy is because you have factoring involved. Okay, let's start by factoring the numerator. If you need scratch paper, I would suggest getting it because it's kind of small. What's the greatest common factor of the numerator? It's what? X, because they all share an X. So if I pull out an X, I want to know what's left.
So you got X squared
minus
X.
X squared what?
Minus 6.
Okay.
And then minus 6.
Good. Is that fully factored? No, because we can use our A equals 1 rule in the inside. Your A is 1. Go do the expanding. A times C is negative 6. B value is negative 1. What factors of negative 6 give you negative 1? Okay, and some of you other people answer besides JC. That would be appreciative. Okay, which one's negative?
3.
3 would be negative. So using my shortcut, X is still going to stay in front because that's your GCF. And then we fill in the other factors. We would get X plus
2
and X minus
3.
3. Okay, we fully factored the numerator. Go rewrite it. Here's our numerator. Let's do the same thing with the denominator. We factor it. Okay, so on the denominator, be careful when you're looking for your GCF. Group 3, what's the GCF? Good. Why is it negative? Because the leading coefficient's negative, you pull out that negative. All right, what do we get left? X squared, because that's going to turn positive. This turns into positive as well. And then this will turn into negative 6. Okay, use your A equals 1 rule. A times C is negative 6. B is positive 1 this time. So it's still going to be 2 and 3, but which one's going to be negative?
2.
The 2. We get the negative 3 in front with your other two factors, x minus 2 and x plus 3. Go fill them in. Okay, any questions on the factoring process? Okay, then look at your notes, ask yourself the question, start with RD. When I look at this, is anything being removed? Okay, well first off, what are the x values that make this undefined? What x values make it undefined? This would be 2, this would be negative 3. Okay, are either of these factors being removed from the fraction? So then for RD, there is none. But since we know that there's still two values that we cannot have, what does that mean? They're both going to be your vertical asymptotes. Can we have two vertical asymptotes? Of course. Okay, last characteristic, HA, which is using your degree rules. So do I look at factors for my degree? No, because that breaks up the exponents. You want to look at the original. Look throughout all the variables. What's the highest exponent of the variables?
3.
So the degree is 3. What's the highest exponent of the variables down here? 2. So same, top heavy, bottom heavy. Which means there's none. No HA. Done with that one. Okay, let's do number 5, and I'm going to graph it with you. Okay, on number 5, we need a factor. Can I factor 4? No, it's just a number, so leave the 4 alone. But I can factor the denominator. What do they have in common? An x. Take out the x, and we're left with 1x, and then minus 3. There you go. Can I do anything else? Do we have any other exponents or greatest common factors?
No.
Nope. So then it's fully factored. Let's get started. RD. Is anything being removed from the denominator?
Nope.
Then there's none. Okay, vertical asymptote. This one's kind of tricky. Remember, vertical asymptote, you ask yourself, what x values will make the denominator 0?
I would make
3. Is that the only one? Because I see that. That would make this factor 0, which makes it all 0. But what about this x? What number could you put right here to where the whole denominator is 0? 0. So x equals 0 is also an asymptote. If I put 0 right there, 0 times anything will still make a denominator of 0. So we have two vertical asymptotes. Okay, the last one, horizontal asymptote. What if you do not have a variable? Because a degree corresponds to a variable. That would be if it was just x. So what if you don't have a variable? It'd be 0 because it only corresponds to variables. If you don't have a variable, then you have a 0 degree. So in the numerator, we have a 0 degree, even though there is an exponent of a 1 here. Yes, I understand that. But degrees correspond to just variables. So if there's no variable, it's 0. What's the degree of the denominator? 2. So top heavy, bottom heavy. Which means the bigger the bottom gets, the closer you're going to get to 0. So y equals 0 would be your HA. Questions on this one? All right, let's go graph it. Starting with our asymptotes. HA is y equals 0. That's here. Then we got our vertical asymptotes at 0 and 3. So here's x equals 0. And x equals 3 would be here. Okay, and a lot of graphing is about estimating pretty much. There's no such thing as a perfect graph with rationals. It's almost impossible, unless you have technology. Okay, so how do I graph this? We go to y equals in our calculator. I already had it in there apparently. And it's probably easier for you guys to use the original one, not the factored one, because the factored one involves a lot more parentheses. Use this one to use less parentheses. So outside of the numerator, we got negative. What is in my numerator? 4 divided by parentheses. What's in the denominator? Okay, push graph to get a preview of what it is that you're doing. So if you look at this, oh, it looks a little weird, but does it match up with where our asymptotes are? Does it look like you have an HA at y equals 0? Yeah, does it look like you have these asymptotes of your VAs right here at 0 and 3? Yeah, so when you go to the table, remember you find points surrounding the what? It's where it says error, but that's your, which of these? The X values, right? The VAs. So when I go to my table, look for 0. There's error, and there's error, because at those asymptotes, your function's not defined. Okay, let's start with the left side of 0. On this side, we want to graph it. Go up. Next point we can put is -1, -1. Here's -1, -1. Next point after that, -2, -0.4. Well, that's a little close to half, way below the 0, so maybe about here. And I'm going to go up again. That one doesn't look that pretty. I'm going to skip around a little bit. I'll do this one, -5, -0.1. That's really close to 0. So we see the curve, yes? Yes. Connect the curve and extend it towards the asymptotes. You graph the first section. Okay, well, don't sit there the whole time just saying, yep, I don't get it, I'm gonna stop.
No.
Okay, try. And I'll see you in the morning. Okay, so now we're gonna go on the other side of 0 in the middle. Going back to 0, in the middle of 0 and 3, they only gave us 2 points. So that's gonna be hard to figure out what the curve looks like. But remember, if you're looking at this preview, it dips down and curves upwards. So when I graph those 2 points, we know that it's going to dip down and curve up towards those asymptotes. So going back to the table, let's graph those 2 points in the middle. We have 1, 2, and 2, 2. And those points are going to be connected with the curve dipping down and going up. There you go, you graphed the middle. And the last section on the opposite side of 3. So we got 4, -1. Then we have 5, -0.4. And 8, -0.1. So we see the curve happening, curve it out, and extend it. Graphed it. Which y'all should be comfortable with this portion because y'all did that whole day. Y'all did like 6 problems, so hopefully you're okay with graphing. The only part that's new today should be just identifying the characteristics. Okay, so I'm gonna give you guys a chance to work it through. I want you to finish what's on the front side at least. These 3 problems are not that difficult because they're not hard to factor. I'll give you a hint. Look at number 8. 8 should be very familiar to you because y'all just did it on your bell ringer. So I already identified all the characteristics with you on 8. You just have to graph it. The other 2 is left for you. Super easy to factor. That should not take you long.